Find the lateral or the curved surface area of a petrol storage tank that is 4.2 meters in diameter and 4.5 meters high. So here is a petrol tank in the form of a cylinder, and we need to find the CSA or the lateral surface area of this tank. The tank is 4.2 meters in diameter, so from here to here it is 4.2 meters. So diameter 4.2 meters. We always need radius, half of it, 2.1 meters, and 4.5 in height, 4.5 meters in height. So the height 4.5 meters. And we need to find the CSA. Now the CSA is this part. This is the CSA. So we need to find the CSA, which is very direct. We see the CSA is, we know the formula, 2 pi r h. We'll put the values. 2, 22 by 7. Your r is 2.1. and your h is 4.5. So when you work this out, your will be 87.12 meters square. First part done. Now we get on to the second part. The second part is here. How much of steel was actually used? If 1/12 of the steel actually used was wasted in making the tank. So here we have a closed tank, right? The answer is 59.346 centimeters square, not that 87 that I wrote earlier. Okay, note the correct answer. Now in the second part we must know how much of steel was actually used. Now to find out the steel, now we know this petrol tank has to be a closed cylinder. So it is a closed cylinder. So if it is a closed cylinder, we require the TSA, which means we require this surface, which we have already found out, and that is this surface, which is the CSA. And then we also require this top surface and this lower surface, which is now these two surfaces, right? So now to find the TSA, we have the yellow surface, which is a CSA, and then we have the red surface, which is pi r square. In this case it is pi r square here, and also pi r square. So this surface would be 2 pi r square, and we know the TSA, if you remember, will be now 2 pi r h, which is the CSA, plus 2 pi r square. You take 2 pi r common out, h plus r. And now let's continue with the calculation. So we have here 2 into 22 over 7, 21 over 10. You know why is it 10? Because this decimal was removed, so we have to put 10 here. And then we add up these. This will come 6.6. So on calculation you will get the answer at 87.12 centimeter square is the TSA of this cylinder. Now we need to find the area of the sheet required. Now here's a sheet of which we are going to make this cylinder, and we already found the TSA. Now while making the cylinder, you will definitely agree that, you know, we cut off the cylinder and the whole sheet is not used. According to the sum, we use only 1/12. So the area of this, will say, is x meter square of this entire sheet that is needed. So area of sheet which we are going to use to make is x meter square. However, they say 1/12 is wasted, so area wasted is 1/12 meter square of this entire. So if 1/12 is wasted, area used up will be x minus 1/12 x, right? That is used up. So that would be, now if you take the LCM, this is 12, this is 12 minus 1, this is x and x, of course. So when you take the LCM, you get 11. So after taking the LCM, you get this. So area used up will be 11, which means, if I were to graphically show it, I would say that this entire area, the entire sheet is not used. A part of the sheet only is used, like this. This part of the sheet is used to make the tank, to make this part, and to make the base. Only part of it, and that part is 11/12x is used, while the other part, that is 1/12x, is not used. So if we look at this, we can say now, here we could say 11x/12 is equal to the TSA. It is the 11/12 that is converted, this 11/12 that is converted into the TSA of this cylinder, while the 1/12 is not used. And if we carry on this calculation, so our x will be equal to 11x/12, and we saw the TSA earlier was 87.12. So x was 87.12 into 12 over 11. So x, which is the area, and now the answer for this x comes as 95.04 meter square. So the entire area of this whole sheet that we have taken is 95.04. However, we don't use all the sheets. We use a part of it. A part of it was unused.